Welcome to the 2023 Geo-Congress in Los Angeles, where leaders in the field of geotechnical engineering gather to discuss the latest developments and trends. This year's theme is sustainability, and we're here to talk with attendees about their organization's efforts to promote sustainable practices in their technology operations.
Aaron, let me get your opinion on some things. For example, what do you think about the role of technology and technology companies in mitigating the climate change issue?
Well, I think technology is personally a necessary evil, but I think it's one of the things that's actually going to propel this industry forward, because I think the instrumentation is going to tell us how the material is acting or reacting to certain forces. So we've been doing a number of studies over the last couple of decades and seeing all sorts of different things and understanding more about the material than we knew before. So I think that the technology is going to be a part of this industry going forward, as much as I might dislike having to use so many different pieces of technology to measure and track things.
Is that why you called it a necessary evil?
I did, because I'm a little bit slow to pick up on all the technology. I went into construction to get away from computers, and here I am using computers every day and new instruments every year.
There's constantly new technologies coming out, so yeah, we could certainly use those technologies to help mitigate climate change. There's a whole variety of different areas where technologies advance so much that we can use that to study climate change, help mitigate climate change, whether it's on land or subsea, in the air. There's multitudes of technologies. These are just ruggedized handheld devices and computers, tablet computers, both Windows and Android devices, so they can be used for a variety of applications, anywhere where you would need a data collection device and it's in a rough environment. You want to make sure the unit can withstand whether it's vibration or weather, water, rain, that sort of thing. So yeah, they're used in all sorts of environments.
So they're a little bit more rugged than your...
Correct, yeah. They're standard Windows and Android devices, but they're designed to be used in all sorts of environments. So mining, inventory control, anywhere where you're worried about dropping a unit, getting it exposed to dust, water. They're built to withstand those sort of conditions.
So we have, quite a suite of software, and we're all connecting that through the cloud to make things, dynamically update and really streamline workflows. Leapfrog is a 3D geological modeling software. It is a really powerful tool. We can import quite a bit of data to visualize in the 3D space, and having that 3D component gives you just a lot of information about your site.
One of the dangers of just having something in 2D is that geologically things can be significantly different just off of that section. And having a 3D picture gives you an idea of where you need more data, where things need to be filled in, where things aren't quite right in the model versus 2D. And actually with how easy it is with Leapfrog to create a 3D geologic model, it takes about the same amount of time to create a 3D geologic model as it does to create a single cross-section in CAD. And then once you have a 3D model, you can have infinite 2D cross-sections to do a 2D analysis if that's what you want to do. But you have the choice coming from a holistic 3D model where you can analyze all of the things like Sean was talking about, all of the things, all of the aspects that you want to put into it. And then you can take those 2D cross-sections out to do your analysis.
Yeah, so they collect data. So these wireless nodes can be set up to monitor the movement of different structural or geotechnical assets. They can be installed on a structure to monitor its rotation, all remotely and automatically without anyone needing to go on site to do it visually. It goes to our cloud software through the gateway device. That's the base station. So all the data from these nodes that we're looking at previously routes through that gateway device before heading up to the internet. where our cloud software is hosted. We do some work with the Class 1 railroads, and when we approach them, we do talk about not just what the sensors can do, but what they help with. And it goes back to that theme I was talking about with removing the need for on-site inspections. Because you can think about the tens of thousands of miles that all these railroads have, bridges, culverts, tunnels, track. To visually inspect all of that is a huge effort. It's a lot of man hours, it's a lot of travel, and this technology removes a lot of that need. Well, I think technology automates a lot of previously manually performed actions. Yeah. I think the main thing, the key thing when it comes to sustainability is, environmental impact, and what we do is that remote monitoring capability.
We are Campbell Scientific, a fairly large company that builds data loggers and different ways to measure sensors and to get that data where it can be useful to people for building models or just for understanding the changes in the environment. Originally, when these were developed, they just stayed, it's like a small computer, so they stayed on a hard drive and then you would go in and pull them out. We're developing cloud technology, so you can put like a cell phone modem on these and it will send it straight to the cloud, and then anybody in your organization can access that. We talk about how big data is becoming more relevant and data-driven decisions. We're hopefully on the forefront of those data-driven decisions, that rather than just sending someone out to look at a dam and hoping that what they see is, to watch a crack propagate is kind of subjective when a person sees it, but if you have an instrument on there, you can get absolute data, and that data will keep people safe. And as our infrastructure ages, it's more important than ever to have that data to keep everyone safe as things degrade. A company used some of our data logging software and some of our instruments for slope stability. They predicted a landslide 17 days before it happened, and then once again it fell, and it was millions and millions of tons of dirt that had slid down. But they had pulled everyone out of that part, and no lives were lost, and everyone was kept safe, and very, very minimal equipment damage. So that's the power of having data and technology to keep not only the workers of these places safe, but everyone downstream from a mine or downstream from a dam or nearby a mine.
Geo-Instruments is an automated instrumentation supplier and service provider. Basically automated instrumentation and monitoring provided real-time, in most cases, to a desktop. I think in the last 20 years, we've started to get automated inclinometers, real-time inclinometers, which is a huge sea change in the way that instrumentation can provide data quickly and more accurate and effective. The age of wireless in the last 10 years has really kind of taken over this market, which is great because it reduces the amount of cabling that we had to do with instruments. A lot of these instruments now on large projects can be just using two different wireless networks. You can have a mesh and a LoRa method, which is a longer distance. A mesh one is kind of, each instrument is its own receiver and transponder, so it sends data around the whole area, and it catches up nodes to jump the data from one node to another. So there's different ways of getting data, and some of it is still direct, a line of sight, but the distances involved are up to like 20 miles. It makes a big change. Before, if you looked at a project, you'd say, oh, I'd have to cable this, and I'd have to have a central control box here to pick that data up, because we don't want a mile long of miles of cabling, so now it's changed the way, you can put instruments where you probably couldn't put them before. And with them being wireless, especially with track monitoring, you can put them on railway tracks, and you don't have all this cabling that used to be a major issue for operators. And a lot of structures now, when you're trying to put a monitoring point on it, they don't want to see it. They want it there, but so with these wireless nodes, they're very small, so you can actually put them very discreetly on buildings, and with them being wireless, there's no cabling to worry about. We all have to contribute somehow, and by using wireless, it's you don't know really what it's going to do to the. Well, it's wireless has been around, and wireless waves are everywhere. But I think in terms of manufacturing cables, disposing of cables, that has to not doing that contributes to climate change in a small way. But when you think about it, how many minerals and processes you have to do to make cable, and then disposing of the cable afterwards. After you finish a job, it's always cut up and sent to landfill. If you can reduce that, then that's a good thing.
Thank you for joining us at the 2023 Geo-Congress, where we've learned about the latest developments in sustainable technology practices. Working together can create a more sustainable future for future generations.